Good afternoon, everybody.
Morning.
So, thanks for your time today. We're going to be talking around disaster recovery and specifically VLR, which is encompassing two products which we are currently working on, kind of like merging together, we will say. So, my name is Ben Fairclough. I've been with VMware for 3 years. Prior to that, I've been a customer for around 20 years of VMware, doing multiple architectures for gaming businesses, retail businesses, banking businesses, etc. After you, Michael.
Afternoon, everybody. Michael Armstrong, Solution Architect. I've been at VMware for 11 years. I've been focused on network security for 5 of those years and for VMware Cloud for the 6 years after that. Like Ben, I was previously a customer, so I used to work for a public sector organisation based in Newcastle.
Right, let's get straight to it. So, what we're talking around is disaster recovery, and especially in the modern day, disaster recovery is very different to what it used to be. We're not just talking about failure of tin hardware, data centres, floods, etc. We're actually talking about a very more specific threat, which is data corruption, cryptography, and ransomware recovery, which is the ultimate statement on there. So, as we're saying, as we're talking around these topics, there's a methodology, process, procedures, runbooks, which have to be very different in how you react to an infrastructure failure to how you actually deal with a ransomware event. For example, like your recovery size. You're not going to want to bring your encrypted services back into an existing data center that's already been hit. You need an isolated recovery environment for that. Recovery points. In an infrastructure failure, 1, 2, you want to get back to the latest point in time. With a ransomware event, you could be reiterating your reiterating your data over months and months of attacks at this point. Networking. There's not a chance on this earth anyone would be wanting to put an infected machine inside an existing production network. Workflow, as I've kind of like gone into, it's more of a linear basis. You have a very specific run book on how you deliver services. Do you deliver the app first, the database first, the app, and then the web, so on and so forth. And these are different, and they cater for your businesses. A workflow for a ransomware event is very much different to that. The basics are the same, but how you iteratively go through and scan and look for data and look for CVEs, very different. And then your special actions. Special actions might be in an infrastructure failure is you run specific scripts to maybe change DNS or change an IP address or do something very much infrastructure specifically. Special actions with ransomware recovery is cleaning that machine, making sure that machine is actually clean, it's safe to be reintroduced back into production, and you're not going to suffer from an attack again. So this is the situation that we're in now, and it's only going to get worse. So an example, you're more likely to be taken down now by a ransomware recovery attack than you are a data center failure. These are statistics that are out there right now. So introducing the two very, I'm going to say very independent, they're very different solutions for different, for these different roles. And this all covers under the VLR umbrella, right? So when we talk about VLR, we actually talk about two products at this moment in time. VMware Live Site Recovery. So you're probably aware, if and if you're not, it's actually SRM, so our Site Recovery Manager. We brought it in, and now we call it VLSR. And there's another product called VLCR. And VLCR, or VCDR is what it once used to be called, that's VMware's Live Cyber Recovery mechanism. So this is something that Joe touched on, which was one of the most compelling elements that he was saying in the keynote, which was we're bringing this on-premise. We've announced it for the Google Cloud, but we're bringing this on-premise as well. And this is really going to help you be able to, shore up your ransomware recovery scenarios and your recovery scenarios in general. So, how do we work with this? How does this look from a VCF perspective? Well, it's an additional SKU, as you know, and that additional SKU is actually based on a per VM SKU, unless you're actually deploying it in the cloud. And at this moment in time, you've only got one option. You've got to deploy it in the cloud as it stands today. However, in the next 6 to 12 months, that will be different. Okay, so it's one VMware license, okay, so one VLR VM SKU and 1 terabyte of storage for the duration of time, okay? So, for example, if you were wanting to just use SRM or VLSR components, you'd buy 1 VM license for that 1 VM. If you were wanting to use that VM for both live cyber recovery and site recovery, that would be 2 VM licenses and 1 X terabytes of storage, as you can see here. So what we do is we pair up the VM licensing to the actual product itself. However, if you're only looking at, say potentially using a set of virtual machines for SRM or VLSR, a set of virtual machines for VLCR, then you can use these licenses interchangeably. So they're not bound to a specific VM. If you buy 100 licenses and you decide one day that 20 of those licenses are no longer SRM relevant and you want to use them for VLCR, you can swap them. That's fine. That's all easily done. The only gotcha at the moment is the terabytes for VLR, and that is because at this moment in time, VLCR as a product, the cyber recovery product, is only available in VMC on AWS. So that's how it's provided at this moment in time. So we're going to build out on this slide a little bit. VMware Live Recovery is actually part of, we'll say, an overall protection mechanism of what you find in VMware Cloud Foundation. Because if you think about VLR as a product, it's always after the fact. It's after a data center explosion. It's after a ransomware event. There's other components in there really that we need to think about as we start to dig a bit deeper. Is how can we actually evade a ransomware recovery? How can we stop these sort of attacks from happening? And this is where like your vDefend, DFW, and ATP, Advanced Threat Protection, comes into place for IDS and IPS. Your platform hardening as well, and all these other solutions that are around that. Now we'll dig into a little bit with VLCR and some of the additional components that you get with VLCR, which you don't get with VLSR. But yeah, just to kind of like stress on there, and we'll move into this slide here, is it's after the fact. So part of the NIST standard or NIST framework is VLR as a product really lives in the respond and recover area. This isn't going to fix your woes of security. This isn't going to fix your woes of I've been hit with CVEs. This isn't going to fix your woes, with antivirus or next generation antivirus. However, if you get hit with something, it will aid in the recovery of that. So VLCR, for example, comes with a product called Carbon Black Cloud, which is able to do behavioral analysis, CVE scanning, and also look for specific malware, which is contributed to there. As Joe said in the keynote as well, it actually uses compression tactics and also deduplication tactics to come out with an entropy, what we call an entropy level, which is this data has changed that significantly. It looks as though something's going on from an encryption event. That could be generic, right? You could be using BitLocker to do something. Likely, it's most of the time, it's something ransomware recovery, okay? So these are the products that are in place. Now, VLCR also integrates very deeply in with NSX. So it's able to provide you with what we call an isolated recovery environment as well, which will give you isolated firewall rules, and it will give you that ability to basically restore that virtual machine quickly and be able to curate that. And we'll get into that. So, differentiators, okay? VLR and VMware, VMware Live Site Recovery as a product, more targeted to VLCR. What does VLCR do today? Well, VLCR gives you a managed IRE. What do we call an IRE? An isolated recovery environment. So that's a physical environment. So that's a VMware cloud on AWS deployment. It's a pilot light. You pay for 2 nodes. It sits there. It integrates directly in to that VLCR distribution. Why is that good? Well, first of all, when you come to restore a virtual machine, you can restore it almost instantaneously. This connects the actual, we call an SCFS in the background. It connects it up and you've got access to it directly. Embedded behavioral analysis. So when you restore these virtual machines, remember it's after the fact, right? So it means someone's already been in there. They've already evaded your next generation antivirus that you may have. They've already come through on a CVE, which you may not have patched, or they've got through it via a spear phishing attempt, and being able to pivot your network. Embedded behavioral analysis gives you the ability, it actually deploys an agent, a Carbon Black Cloud agent in there, and it actually analyzes how the machine's behaving, what CVEs are outstanding against it based upon the Carbon Black Cloud footprint that we have, so it's all online. And it'll also give you any offline or any fileless attacks based upon there. So that's really important because again, like I said, we're after the fact here. We need to know what's happened. Has this box been the source of that attack, or is it just being a victim of that said attack? Dedicated end-to-end workflow. So we've talked about the embedded behavioral analysis and we talked about just one machine. The likelihood is if you have been hit with a ransomware attack, they've not just hit one machine, they've hit tens, hundreds, if not thousands. VLCR has a full end-to-end workflow, so it's not just going to be one person working on this. You're going to have tens, maybe 20s, maybe hundreds of engineers working through iteratively trying to restore these virtual machines back to as best a state as possible. And let's be real about this, right? You're never going to get 100% data recovery if you're being hit by a time-bombed cryptographic attack. It's just not possible. But what this will give you is it will give you a central console of view, a central view console for multiple engineers to work together, tag, isolate, reiterate, and curate these images as you're going through. Okay, and that kind of moves on to the rapid reiteration. We're able to restore snapshots quickly. We're able to restore files and curate these images very quickly. So VLR, what does it actually look like? So we call this the services portal now. We used to call it the CSP, but now it's the services portal because this is what you're going to kind of like see now going forward from a VLR perspective. And it's going to give you the capabilities of being able to set up deployments. Now, when you click on set up deployments, it's going to give you the ability to set up Site Recovery Manager or VLSR. It's going to give you the ability to set up VLCR. It's also going to give you the ability to import any existing SRM or VLSR deployment that you may have. And then it'll give you the list of deployments, the upgrades. This is your central console, right? Doesn't mean it's all going to change on how you configure it, because then you move into your separate elements there. So you can see what you've got in terms of live site recovery and what you've got in live cyber recovery. So these are the consoles that, well, you may know already, so for example, VLSR, or you may be coming to get to know, which is VLCR, which is a relatively newer product in comparison. But it will give you them independent views. So how do we get it all put together? How does it all look? How does replication happen? Well, we use replication with VLSR and VLCR in two different methodologies. VMware Live Site Recovery, or SRM, has always been branded as a DR orchestrator. So this is a manager that's going to be able to command your replication, to be able to do your replication. Then use vSphere replication as an appliance if you want to do vSphere VM level replication, or array-based replication, or vVol replication. And that still is the same as today. You still leverage other utilities and components in VLSR to actually achieve your DR desire. VMware Live Cyber Recovery works very differently under the hood. It works only with VMs, and we really leverage quite a lot of the latest snapshot technology, HFS, lightweight deltas, and then we can also go back to the good old traditional VADP in relation to that. So, similarities. What are the basics? What do both of these products really, from a synergy perspective, have? Okay, they have protection groups. They have site mappings and they have recovery plans. Really the bare bones of what am I going to protect, what maps to what, so what network goes to what network, folder to folder, recovery plan to recovery plan. That's how it looks. So when you set this up, you set up your data replication, as we've just discussed with VLR. You configure your protection groups. So these are my groups of protected virtual machines. I've got a web tier, an app tier, DB tier, a finance tier. You set them up in the relation to where you want them. You set your site pairing and your mapping of how all that looks, in terms of it. So if I ever come to a restore point, what network maps to what network, what resource pool maps to what resource pool, clusters to clusters, so on and so forth. And then you build your recovery plans off the back of it. So in the event of X and Y, I want to power on Z, Y, and X servers ultimately. So protection groups, how it looks like in VLSR. So if you're not familiar with SRM, VLSR, ultimately you go into your protection groups. In here you can see we've got a number of protection groups here. We're going to add one, so we give it a name, we give it a direction, we select the virtual machines, and away we go. Ultimately, that's how it works. In VLCR, I say very similar naming, but we create a protection group on the top here. In here, we give it a name, okay? We tell it whether we want to use high-frequency snapshots, so that's that lightweight deltas that I've just been referring to you about, or VADP. We can QS it. We give it a pattern, or we can select virtual machines. So we're a bit more selective with what we want to do with VLCR, and we can also exclude certain things. The other part with the protection group is we actually apply a protection schedule as well off the back of it. Sorry. There's a protection schedule will give you the ability of being able to say, right, I want this backed up every hour, and then retained for a day, every day, and retained for a week, every week, and retained for a month, for example. You do the preview. Sorry, this is a protection schedule here. I've skipped ahead rather than behind. But yeah, as I've just described, you create your schedules off the back of this. So these protection schedules take into account their ransomware recovery minded. So, you want to retain certain levels of data for so long so you can iteratively go back through that restore mechanism. And you'll see the protection group as it stands there. The next is site mappings for VLSR. So how do we create the site mappings? Site mappings in VLSR are very different. You can see you've got network mappings, folder mappings, resource mappings, storage policies, and so forth. So you go through this in the same way as what you would. You go to folder mappings, you create a mapping, and you say, my training folder, for example, here relates to the training folder in my other data center. Cluster 1 maps to cluster 2, and my storage policy mappings map to the other storage policy mappings. And this could be related to having a physical piece of hardware, a physical array on-premise versus a vSAN cluster in the cloud or somewhere else, for example. With VLCR, the mappings is all done inside the actual recovery plan itself, and you can actually build that out. As you can see here, we're building the failover mapping for virtual networks, vCenter folders here, your compute resources. If you keep in mind, it's basically the same thing. The synergies are there in relation to that, and the sites. So, the recovery plan steps. So recovery plan steps for VLSR are quite simple. You go through in terms of the recovery plan, and you tell it effectively what protection group you want. You tell it what virtual machines you want to go through, and then you go through the recovery steps. Now the recovery steps look very different to VLCR, but they're pretty much in the same essence of it. You can select what virtual machines are prioritized, what scripts you want to run, what IP addresses you want to change, if any. You can go through that basis. Once you're in that situation there, you're literally ready then to actually run your recovery plan itself. With VLCR, it's exactly the same mantra. We'll say you go through, you create your plan, you add your recovery steps. Now the recovery step screen looks slightly different, but in essence it's pretty much the same element there. You go through there, you power on which protection groups you want to bring online, and then you can set your power on order, whether you want certain elements to be installed with Carbon Black Cloud as an example. These are all the options that you'll get off the back of that, as you can see here. So, VLR replication. Okay, VLR replication itself is in two different varied ways, as I've just kind of discussed with you. So you've got the basics. You've got your production site and your recovery site. Now, your production site, recovery site might use a different level of infrastructure and technologies off the back of it. So with VLSR, you deploy VLSR, and then you can either enable vVol replication, you can enable vSphere replication, for example. It's all there, it's all configured in there. Now with VLCR, VLCR is different. VLCR is like an agent. You actually deploy what we call a DR as a service orchestrator, which is a virtual machine. It integrates into your vCenter, and it communicates with the hypervisors and the hosts. And what it does ultimately is it chats to the SAS orchestrator, which is actually the VCDR console itself, you would say, and the scale-out cloud file system. Now, it does that via TLS 1.2, and it can do that via public means, so via the internet, or it can do it privately at the moment. Just take into account we're on VMware Cloud and AWS at the moment, so that'll be via Direct Connect, ultimately, using a private, using a private VIF, or it can be done effectively publicly through the internet itself. And what we'll do is that SAS orchestrator will command that DR as a service connector to take the snapshots and stream the data to the scale-out cloud file system. Now, as Joe mentioned, the scale-out cloud file system is immutable, and it's one of the very few products where you can actually say, hand on heart, it is truly immutable. So when it does bring this data into SCFS, the data is brought into a cache first, where hashes are built on there, and it uses Merkle tree cryptography on top of it to store the data into an S3 bucket. And what Merkle tree cryptography, very top level, it's like a ledger, it's a bit like a crypto ledger, which means that the hashes are generated on the previous hash, which means if a threat actor was to ever get into that SCFS and modify it, you'd know straight away because the chain of command is broken. So you know exactly where your source point, where your source point is at that point. I'm going to hand over to Michael now for the rest of live cyber recovery, but thanks for your time.
Thank you. I think you pitched the last two slides.
Might have done it.
Yeah, so I'm going to spend a bit more time going through the whole VLCR workflow. So how do we actually go through a simulated sort of, you've had ransomware hit, and how do you go about recovering and finding out which snapshot you should look at recovering first, and recovering files and all that sort of stuff. So a little bit more about VMware Live Cyber Recovery. So I don't like this term air-gapped, okay? So if it was air-gapped, we wouldn't have any ability to get the data actually into the scale-out cloud file system, okay? But this is as air-gapped as it can be, okay? So because the service is running in AWS, and it will be launched in Google Cloud probably early next year, we still need to be able to replicate that data in there. Okay, so we do have specific ports open for those connector appliances to replicate their data into the scale-out cloud file system. Okay, as Ben mentioned, it uses TLS 1.2, but as I said, it's as air-gapped as it can be. There's only the specific ports that need to be open are open. We can lock it down so that only the connectors, public IP addresses that get natted outbound, can talk to the scale-out cloud file system. But it's not fully air-gapped, okay? I don't think the ability to switch on that air gap and then switch it off when you need to replicate is really going to work long term, because you're going to have various schedules replicating data at certain times, offset by every 10, 15, 20 minutes. It'll be coming on, off, on, off, on, off all the time. So when you see this, when it says air gapped, it's sort of air gapped. Okay? It's as best it can be. Instant power on. This is one of the key things. Okay, so that scale out cloud file system is actually an NFS server. Yeah, we can mount one of those NFS shares directly to that isolated recovery environment. Okay, so we don't have to rehydrate any backups or anything from either S3 or from on-prem or from wherever. We can literally mount that NFS share, power on that VM from that NFS share, identify very, very quickly whether it's encrypted or not, and if it is, we just discard it and go to the next snapshot or the previous snapshot. So when it comes through to iterating through this process as fast as possible, because we're not having to rehydrate any data, that's how we can get through there. I'll cover off the ransomware recovery workflow as we sort of go through, but the key bit, and you'll see through the screenshots, is all around the guided restore point. So how do we help you identify which is the best snapshot to be able to recover your VM image from, and then also potentially where do we then start to recover from some of the files and folders from? Because what we ideally want to do is recover the VM from prior to infection and then get it patched, and then recover the data to prior to it actually the ransomware event, which is going to encrypt everything. So that's the sweet spot, unless you just take the approach of rebuilding the VM from scratch, but that depends on the automation that you've got in place. I'll also cover a bit more around the IRE and the VM isolation, and also the next-gen AV as we're going through as well. So as Ben mentioned, all of this portion, so from this bit onwards, is basically currently running in AWS. Okay, so GCVE or support for Google is coming early next year. So we have our on-premises environment. This can also be a cloud environment. So this can be VMware Cloud and AWS as well, or it can be GCV we support. We deploy the DRaaS connector, just a virtual appliance. Yeah, so there's no requirement for any physical hardware or anything like that. We can deploy multiple connectors for availability and for improved throughput. We then basically select which workloads we want to replicate into the scale-out cloud file system. And that's all done via the SaaS orchestrator. Yeah, we specify based on the protection schedule how often we want to replicate and how long we want to keep those snapshots for. All of that is stored in scale-out cloud file system. And as we said, this is all fully immutable. Now, you can leave it like that if you want. Okay, so if you don't need to do testing every week, day, month, or whatever, and you're more cost conscious, you don't need the isolated recovery environment. You can deploy that on demand, sort of on demand, if you need it. Okay, so if you're more cost conscious, you might just want this, but actually then when it comes to doing testing or actually doing a DR event, then you spin up the SDDC, we'll automatically mount this scale-out cloud file system, and then you can start running through the workload. That very much depends on what your RPO and your RTOs are. Okay? If your RTO, your recovery time objective, is an hour, you're not going to spin up that SDDC and get the connectivity and everything in place in an hour. It takes us at minimum about 2.5 hours to deploy an SDDC. But if your RTO is 8 hours, then yeah, that's doable, and that's maybe the more cost-conscious approach to it. Okay, so what we tend to see with customers is they actually do what we call a pilot light. So they have a bare minimum deployment, which is currently 2 nodes, yeah, so 2 VMC nodes, sitting there permanently that they use for application testing. You can even run production workloads on there or test and dev workloads. Just bear in mind that when it comes to potentially invoking DR or running through the cyber recovery workflow, you might need to free up some capacity in that recovery site. But once again, you've got the option of doing however you want to do that based on cost factors. So we're going to sort of walk through each of these steps as we go through. So the first point is we need to ensure that we have configured an adequate protection schedule. Okay, so there's no point in just setting this to maybe say, right, I want to replicate every half hour, but I want to keep it for a day, because the furthest you can go back at that point is a day. From a ransomware perspective, dwell times typically between 45 and 90 days. So ideally, you want to go back at least a bare minimum of 3 months, ideally more. Okay. The downside of that is there's generally the cost goes up, but once again, it's cost versus being able to recover in the event of a ransomware workflow. We typically recommend 6 months worth of retention, okay? But once again, it's entirely up to you. In this one here, we're doing half-hourly snapshots. We're keeping them for 2 hours. We're doing every 4 hours for 2 days. We're doing daily for 7 days, weekly for 4 weeks, and then monthly for 4 months. You can keep this for as long as you want. Yeah, it's just storage that's being built on the back end. So if you want to keep it for 2 years, 3 years, that's absolutely fine. There's just a cost associated with keeping that. The first snapshot is a full snapshot. All other snapshots are incremental. Okay, we use change block tracking to identify what blocks have changed, and then we just replicate the changed blocks, like all backup solutions and replication solutions typically do. Okay, so we've now got our VMs are protected. They're replicating every 4 hours or every half hour, and then we're retaining that for, let's say, 6 months or 9 months going forward. For cyber recovery and for doing disaster recovery, we first of all need to deploy an SDDC if we haven't already got one. Okay? As I said, most customers will typically have a 2-node SDDC ready and waiting, and then they scale that up if they need additional capacity, because based on the recovery time objectives, they need a recovery SDDC up and running. But this is literally a case of going into the console, adding a recovery SDDC, 2.5 hours to deploy this, and at that point you have a fully deployed SDDC running on bare metal AWS hardware, and in which case this is where we can then start running through this workflow in order to recover workloads. We also deploy the carbon black appliances that are sitting in there to do a lot of the analysis, and then that also reaches back out to Carbon Black Cloud in order to pull down updates and things like that. When you log into vCenter, we also pre-create a whole bunch of NSX rules. Okay, so if you're not familiar with NSX, we have the ability to use what we call the distributed firewall, which is your ability to basically stake a layer 4 or layer 7 firewall around every single virtual machine, whether they are on the same layer 2 segment or not. Okay, so when it comes to being able to iteratively go through workloads that could potentially be impacted with ransomware, ideally what we want to do is recover it in a completely isolated bubble so that it can't talk or reinfect anything else that's either on that same network or on a different network, or potentially has access back to on-premises. And if you think about how you would do that on-prem without NSX, how would you wrap a firewall, unless you do it inside the guest, how would you wrap a firewall around every single workload? It's actually quite difficult to do. I said we've got a whole bunch of pre-created rules that when we tag a virtual machine as we go through the process, we can start unrestricting its access. Okay, so by default, it's not allowed to talk to anything. Maybe as we start investigating, maybe we start opening it up so that our on-premises security tools can talk to it. Or maybe we actually allow it access to talk to the internet, but nothing back on premises. And you can modify these rules as well. So you can add your own rules and IP addresses and things like that. Okay, so the idea is that as we become more comfortable with this workload, that it's safe, we'll then start unrestricting its access and allow it to start talking to more things on the network. We then enter this guided workflow. Okay, so the recovery plans that Ben was talking about, we initiate the guided recovery workflow on one of those recovery plans. And it'll basically list all of the servers that we have. And you'll see that we've got these various states at the top. Okay, so it's in backup, i.e. that VM is just in the scale-out cloud file system. It's not doing anything. We haven't started going through this process. It could be in validation, in which case we've powered it on instantly. Yeah, so it's running from that scale-out cloud file system. And maybe we're deploying Carbon Black, and we're starting to go through some of the scanning inside Carbon Black. It can be at a staged, yeah. So we've gone through the Carbon Black workflows. We're happy that this VM is relatively safe. We've recovered all of our files. We've then staged it, and then we look to recover it back to on-prem, or maybe we just leave it running in the recovery environment. We just open it up so that we allow access from our on-premises or from our customers or whoever's using that application. And then obviously we've got the various transition stages as we're moving between those various stages. We then have the ability to filter, because as Ben mentioned, you could have tens or 20s of people working through these VMs individually. Yeah, so you might have certain people working on a certain application and other people working on another application. So as you're going through, you can see exactly who's doing what within each of these virtual machines. We've then got this. So this is the interesting part that I think, personally speaking. So this is how we guide you into which snapshot is potentially the best to look at. Okay, so we pick up two things. Actually, on Windows VMs, we pick up, I think it's 5 metrics. So things like files changed and change date and stuff like that. But generally, we look at the change rate. Okay, so what has changed since the last snapshot, and entropy. Okay, so entropy is a value of between 0 and 1, and it's how compressible is that data. Okay, so a lot of files, a lot of folders, etc. are compressible. But if everything is encrypted, there's a good chance that none of those files are compressible, in which case the entropy will be 1. Okay, so that's what we'll use to sort of try and identify where's the best snapshot to look at. So we can see that our change rate is changing slightly, and we can see that our entropy is relatively low at this point. So hands up if you want to have a guess where I would probably start looking. Exactly, yeah, where does it sort of make sense? Well, if you look at there, our change rate's starting to get a bit higher, and our entropy is starting to get a bit higher. So this is most likely where we've had an encryption event. Okay, we've had a lot of files changed, more than normal, and the entropy is a lot higher than normal. So if I was going to start looking at this, I would probably start picking one of these snapshots that is prior to that event. You might have got it wrong. You might have hit it just at the point where it's starting to encrypt at this point. The benefit of this is, once again, is we can iteratively go through this process as quick as possible. I can power on, let's say, that snapshot there, just next to the 8th of November, have a quick look. Yeah, that's encrypted, delete it, do the next one. And all that literally takes is the amount of time it takes for that virtual machine to power on. So the further back you go, the higher the risk that you've got of those workloads still being encrypted. But the further snapshot-wise you go out, the more data loss you're going to have. So what it might be is you might recover the virtual machine from somewhere back here, and then you might start to recover the data somewhere around there just before the actual encryption event, so that you've got the most recent copy of that data. So once you've picked your snapshot, you've picked the one that you want to go through, we can then install the Carbon Black agent. So the agent gets automatically installed on both Windows and Linux VMs. If you don't want to use Carbon Black, you can specify in the recovery plan that you want to deploy your own sensor or your own software, in which case what will happen is that VM will just pause. You'll then have to log in or automate the deployment of that, and then you can use your own tooling for vulnerability assessments and scanning and things like that. As I said, by default, we'll deploy Carbon Black inside there, and that will do your scanning and vulnerability assessments. Once that's ran, you'll then get a whole bunch of information that states, right, what are some of the alerts that we've seen, and what are, I think there's the one for vulnerabilities. There's that. What the threat level is, what the threat type is, and then basically some information about that. And once again, that's using Carbon Black agent and the Carbon Black sensors to be able to identify that, and it'll pull out all the CVEs, and hopefully you get an indication of how that workload was compromised and what you need to do in order to patch that workload. You can also go straight into Carbon Black as well, so if you want to actually go in and get more information directly from Carbon Black, you can launch Carbon Black from within context of VLCR. At that point, so we've got the agents installed, we've gone through the VMs in the isolated recovery environment, we're working through it, we've started to recover some of the VMs, some of the files from that VM, so maybe we go to the last snapshot, the last known good snapshot, and copy some files and folders that are critical, that we need. We can start doing that and getting this VM into a point whereby we're happy that it's as up to date as we can get it, and in which case what we'll then do is we can then start looking to stage it. But what we can do first, as I said, is we can start opening it up to, or start giving it more access. By default, it will take this isolated tag and it won't be able to talk to anything. But actually, now that we've quarantined it, we're doing some analysis, so that allows us to talk to Carbon Black. We might want to allow it to talk external or talk internal, or we can fully open it. And that's all using NSX distributed firewall, which is all included as part of this. There's no additional SKUs or anything like that. More importantly, as I said, you can create your own. Okay, so you can create your own policies and apply those policies so that it can talk to certain networks and maybe not other networks and all that sort of stuff. The good thing as well is as you're working through this, I don't think there's a slide for it. No, there's not. You can actually tag these VMs. Okay, so as you're going through this, if you go through a particular snapshot and you find that it's encrypted, you can actually badge it and say this VM is not good. It's still encrypted. It's not a good candidate. So that anybody else who's going through that workflow can see straight away that you've tried that snapshot. It's not good. So you then go to the previous snapshot. Okay, so everybody who's working on from an incident management perspective can obviously get an understanding of actually what's going on. At that point, we're then ready to stage it, and what we do from a staging perspective is we then shut down that VM and we take a final snapshot. Okay, so that is the VM as it is now, with you going through all the workflow, making sure it's up to date with the latest files and everything. And at that point, it's staged and it's ready to be replicated back to the on-premises environment. Okay, so it's staged. We can either recover it back to on-prem. If your on-premises environment is you're still trying to do go through like incident management and find out actually what's happened. So maybe you're not allowed to destroy any of the data that you've got on-prem because GCHQ or somebody actually wants to investigate to find out what's happened. You can then recover to a different site. If you don't have the hardware or another environment ready and waiting to replicate to, you can just keep the workload running in the protected site. Okay, so you've got the option of where you want to recover that to. And then at that point, what we'll do is we'll replicate that VM back to the on-premises side, and then we can power it on, and it's as if it was back to the stage at which we recovered it from. Okay, so your workload is then copied back to on-prem, and it's running on-prem. The only issue with that is, depending on what happened to the on-premises environment, i.e. if everything was fully encrypted, you're going to have to copy all of that data back across again. Okay, when we recover from a traditional disaster recovery, we assume that maybe 90% of the data is on-prem, and we just need to replicate the 10% delta changes. With an encryption event, that's not the case, because everything is fully encrypted, so we have to do 100% data copy back to on-prem. Now, if you're using Snapshot Manager, so within VCF 5.2, I think it came out in, you have the ability to use Snapshot Manager, whereby we can take snapshots of VMs on premises, we can keep it in Snapshot Manager, and we keep a copy of that data, and once again, that's immutable. VLR can actually talk to Snapshot Manager and say, actually, recover this snapshot because it contains 90% of the blocks that I need, and then all I need to do at that point is just copy back the 10%. Okay, so rather than having to recover 100% of the blocks, 90% is restored locally, the 10% is restored from the cloud back to on-prem. So it just streamlines the recovery process. What might or might not happen, I think Joe talked about it, so I probably can't mention it, is this functionality, but on premises. Okay, so maybe being able to replicate from one site to another site, and then having this VLR UI on premises to be able to take you through that guided workflow. That's what they're aiming at with regards to VCF 9, because some customers maybe don't want to use cloud for this. Okay, so hopefully we've talked about two different use cases. So disaster recovery, VLCR and VLSR, and the cyber recovery side of things with VLCR. And on that point, I'll open it up to questions. Any difficult ones, go to Ben. I'll take the easy ones. Yes?
In terms of the snapshots and mutability, are you able to protect, say, if you've got the local snapshots? I mean, the risks are quite high that they might get infected by the time you find out. So.
They can't be changed. Once that data has been written to that scale-out client file system, it cannot be modified any way, shape. It's not as if it's connected to your on-premises, so it's not like a CIF share that can be accessed or anything. It can only be accessed via TLS in certain ports. But once that data has been written, that data cannot be modified, and the only thing that will get rid of it is once it's aged out. So if you have a retention policy for 6 months, 6 months in 1 day, it will just delete itself.
So is this available in vSphere, in terms of, I think in the main sort of speech, you were saying that for on-site, on-prem, it's not available.
It's coming.
It's coming. So,
Yeah.
so if you wanted to protect workloads now, you would have to protect it currently to VMware Cloud and AWS. So it only works in VMware Cloud and AWS at the moment. Google is coming probably early next year, and then an on-premises equivalent version is coming later down the line. Yeah. But in order to go from having absolutely nothing to having your workloads protected, I mean, we do POCs, and we can typically do that in about 4 hours, and having the first set of data replicated in about 4 hours. That's deploying all of the workloads, configuring the policies and everything. So it's very, very quick to get at a point where you have your workloads protected elsewhere, not necessarily on-prem with backups.
You talked about when you thought that maybe the encryption was happening,
Yeah.
potentially. So how easy is that to interrogate, to find out? Because you might be encrypting your data anyway, and that spike could have been a genuine spike. So how easy is it to drill down and then sort of find out what's happening?
Yeah, so I only covered the two main ones here, which were your change rate and entropy. So with, I don't know what we do with Linux, but with Windows VMs, we also look at like when the last file was last updated. So if we're seeing a lot of files being updated on a certain date, then that will trigger as well. I think there's like, if I get the new slide, there's probably about 5 or 6 different metrics that we now start looking at to try and help you identify which is a known good candidate.
Yeah, I mean, when you are running encryption tactics like BitLocker, for example, and this is quite prevalent. Let's be honest with you. Right now, attackers are not using specific malware to encrypt your devices. They're actually using things that are in there now, like BitLocker. And it's actually to be honest with you, it's quite relevant. So right now, there's no patch for it as it stands. There's bugs in Mozilla and Google Chrome with Windows 11, which can put end user run times effectively for a hacker if they was to exploit that current CVE. Now, that's being fixed as we speak, but if I'm a threat actor, I'm in and I'm going to start using BitLocker. I'm not just using BitLocker on your local laptop that you've got there. I've just exploited you. I'm going to look for a file share. So what you see here, it's very unlikely that your BitLockered machine or what you see on this server is going to marry up. If you see entropy changing at that rate, you're going to be right in there. So the threat is real. This is a real scenario. No, this isn't a real scenario, clearly. But the threat is real there, and it is possible to have this done to you today.
I'm so sorry, we've been told to stop,
Yeah.
but we'll both be outside if there's any more questions or anything going forward. Happy to just grab us. We'll be here for the rest of the day as well. Thank you.